Hi, welcome to In 5 Minutes. Today's concept is the transistor as a switch. We are going to study how the transistor can be operated as a switch. We have seen different application of transistors. What are the different applications? It can be used as an amplifier, it can be used as a switch, or it can be used in integrated circuits. From this, how we are using it as switch, that we are going to see now. Now, when you look at the diagram, it is which type of transistor? Arrow is always from P to N and the other terminal will be N. So it is NPN type of transistor. What are your emitter, base and collectors? When you look at the diagram, this is your base. Output from where you are taking is your collector and this is your emitter. You can see in the diagram, where is your input applied? Input is applied to base. Output is taken from collector. So what you can say, emitter is common to base and collector, so the configuration is common emitter. So how to identify the configuration is, just look at the input where it is applied and from where you are taking the output. The other terminal will be the common terminal. So in this case, emitter is common to base and collector, hence the configuration is common emitter configuration. Again, NPN type. Right now, in order to operate as a switch, first we need to see the base emitter junction. We have seen the transistor has two junctions. In order to operate the transistor as a switch, JBE and JBC, in order to make it off, we need to reverse bias both the junctions, right? We need to forward bias both the junctions. That is, we need to move it to the saturation region. Transistor should move to the saturation region, then only it is on and with maximum current. Whereas in order to turn off, we need to make both the junctions reverse biased, right? So initially, now to start with, consider the base emitter junction. Can consider a diode like this. So in order to forward bias the diode, how much voltage is required? You need to provide the voltage. This voltage should be greater than 0.7 volts. Now in our case, if Vi voltage is say 0 volts, my input voltage is 0 volt, what will happen in the circuit? Can say to the positive terminal, this voltage, instead of giving 7 volts, I am providing the voltage as 0 volts. What will happen? The diode will be forward biased or reverse biased? Diode won't be forward biased, it will be remaining off, you can say. So when the diode is off, what is the value of IB? When the current will flow through the diode? Only when you are providing voltage greater than 0.7 volts. Since your voltage is less than 0.7 volts, say 0 volt, then no current will flow to the diode. So the current IB will be 0. As you know, IC is nothing but beta times IB. If IB is 0, my IC will be 0. When IC is 0, the current through this collector resistance is 0. How I am writing VO? My VO equation will be, when you are applying KVL in the above part, you can say KVL from this point to VO. This is my RC plus VCC. When I am applying KVL from this point to this point, positive, negative. So VCC minus ICRC minus VO, because this is positive terminal, we are living with negative sign, hence we are living with positive sign, hence positive, equals to 0. So my VO will be VCC minus IC into RC. Now in this case I am getting IC as 0. So what will my value of VO? It will be VCC, since the collector current is 0. Since the current is 0, if I am having any appliance connected over here, for example, now load can be what? A motor, LED lighting, anything through which you want to pass the current. If my collector current is 0, no current will flow through the motor or LED, so they will be off. And what VO I am getting? Which is equivalent to VCC, right? Now in the next case, if I am providing voltage Vi to be greater than 0 volts, say VCC. If I am providing Vi to be VCC, what will happen to the circuit? Say from this condition, in the previous case I was in the off condition. Now what I am doing, I am providing Vi to be say VCC. If my input voltage is maximum VCC, what will happen in this case? IB will flow. What will be the equation for IB when you apply KVL in this loop? It will be Vi minus VBE on divided by the resistance RB. And what will be IC? IC will be in the saturation region. What will be the value of IC sat? VCC minus VCE sat divided by RC. Now how you got this equation? Applying KVL to the base emitter loop. KVL to base emitter loop will give you this equation and KVL to collector emitter loop will give you this equation. This I am writing just short form. When you are starting VCC minus IC into RC, if the resistance here I am considering ICRC minus VCE, and since there is no resistance in the emitter, we need not consider it, so you will get IC as VCC minus VCE sat upon RC. Now the current flowing through this load will be maximum. So in the previous case, when the current was not flowing to the motor or LED was not glowing and the current through the motor was 0, so motor was not turned on. Now when you have maximum current, motor will be turned on and LED will glow depending on the value of the current. This is how the transistor is acting as a switch.